Computer Science and at the Faculty of New Science and Technology, University of Tehran. He received his PhD degree in Computer Engineering at Sharif University of Technology. His research area are digital signal processing, speech processing, natural language processing, and artificial neural network, and also deep learning. So, Dr. Hadi, you have 20 minutes to present your work. And regarding the question, we will take the question after the second presentation.
Okay, thank you very much. Hello, everybody, and good morning. Thank you, Dr. Abdulbasit, for your invitation, and I want to thank all of the organizers of this event at the University of کۆیە. سڵاو ڕێزم هەیە بۆ تەواوی بینەران و بیسەرانی ئەم لێکچەرە. I shared my screen and I guess that you have my screen now. As it's mentioned, my lecture is entitled Kurdish Spoken Language Processing, which is a work, it's about 7 years of experience in Kurdish spoken language processing from our team, which you can see the name of some of them here. As you know, language is the very primary tool for the communication and can be roughly categorized into spoken language and written language. By spoken language, we mean speaking, and the outputs of the spoken language is a speech, of course. However, there are another language which we call written language. The output of this language is text. As you know, the basic unit for having a written language is called alphabet, character, or letter, and the similar way we have the basic unit of spoken language which we call a phoneme. There are various number of characters and also phoneme in different language. For example, English has 26 letters but has more than 40 phonemes. This is the similar way for Kurdish, Central Kurdish. We have 34 letters but more than that, 37 phonemes. Spoken language, of course, is the first and the simplest communication tool for the human being because it's natural. It requires no training. It's very completed and is far more polluted than the written language because the history of spoken language is in the order of million years. However, for the written language is order of the I think about 300 years. Spoken language is more efficient than the written language because we can transfer high data rate. However, it's very flexible, expressive. We can express our emotions in addition to transferring the information. It's just very popular and of course economical. So speech interfaces could be ideal for information access and management when the information space is broad and complex. For example, when a human being can talk with a robot or two robots can talk together. As mentioned, there is no one-to-one mapping between spoken and written units. However, there are some languages that we call them phonetic language that have nearly one-to-one correspondence between written and spoken units. For example, in English, we have some phonemes that can be written in different forms, and we have some letters that can be pronounced in different phonemes. This is the same for the Persian and for the other language. We have two letters in Kurdish that each of them have two different pronunciations. Central Kurdish language has 37 phonemes, 29 of them are consonant and 8 of them are vowels. Among these vowels, we have a vowel called bizroka, this last one, which is not written in the Arabic script form in Central Kurdish. By spoken language processing, we mean how we can develop a system and or algorithms which can speak, hear, understand the speech just like the human. And of course, it will be our target in developing spoken language processing to become the speech as the first communication between human and machines, or even between machine and machines. There are various applications for spoken language processing which are not new for you. All of you, of course, are familiar with most of them. For example, automatic speech recognition. Nowadays you can find several versions of them on your cell phone to convert speech into text. However, there is another technology related to speech recognition which we call speech retrieval. I will talk about that in the next slides. Another application is text-to-speech, which aim is to convert text into the natural speech. Another related technology is voice conversion, which it means we convert someone's voice to another one. Also, chatbot and dialogue system or digital assistant are another application of these technologies. Language identification and dialect recognition is another one. Speaker recognition generally, which include the recognizing the speaker identity or speaker emotion, or also other related technologies like anti-spoofing, voice anti-spoofing, of course. There are some language independent. This type of technology, of course, are language dependent. For example, automatic speech recognition in Kurdish is different from that for English and for other language. However, there are some applications that are generally, we can call them signal processing, not speech processing. So they are language independent. For example, speech denoising or speech coding, which speech steganography or audio steganography is among of them. Also, we can name some hybrid applications such as voice translator or speech-to-speech translations. As the first application, automatic speech recognition, as you know, converts the speech into the text, just text, not semantic and meaning. There are many applications for speech recognition, such as voice dictation, voice command to robot, cars, smart home, and other hardware, or converting the lectures, for example, the lectures in this conference into the text, or automatically subtitling the movie or video, as you can see this technology in some websites such as YouTube. Also, speech recognition can be a part of other systems, for example, in digital assistants, voice translator, other technology. it's about 70 years of history for speech recognition. The primary works started by large companies such as IBM, and the funds that are provided were provided and still is provided by DARPA. The DARPA fund result in many good outputs in this area, among of them the Carnegie Mellon University works such as Sphinx open source project. Maybe the first commercial ASR system is IBM Via Voice, which is developed among these years, and after that we can name the Dragon Dictate, which is now still purchased by a company named Nuance. After 2000, the ASR technology is boosted very rapidly grows by companies such as Microsoft, Google, Apple, Amazon, and other companies, and there are many, as you know, applications nowadays for this technology. For example, according to the formal reports of Amazon company, there are more than 100 million Alexa gadgets purchased, which is equated with speech recognition. Now, the speech recognition is provided by these companies. For example, Google Cloud now support 149 languages, but Kurdish is not among them. However, as you know, the last week Google announced adding a central Kurdish to the Google Translate. However, for the speech to text and text to speech services, we don't have such ability. The performance of speech recognition systems now are very acceptable. For example, on clean audiobook, we receive about 100 word error rate, which is of course very acceptable. However, this is not very interesting for the noisy conditions such as dinner parties, and we have still a lot of distance to have a better recognition systems. I have a very summarization of speech recognition research. As you know, as in your case, you can see there is a very short history for speech recognition in Kurdish, and there are some we have some limited tries to develop speech recognition in Kurdish. Among of them, the Dinler work, which aim is to recognizing only 10 digits of Kermanji, and they have collected 5,100 samples of samples for only digit recognition. Another work for developing another try for developing a speech recognition system, record the 2,000 sentence only by one speaker and use a very small corpus, including only less than 300 tokens, and use Sphinx to recognizing the sentence. Of course, it's a very small corpus to have a continuous speech recognition system. Also, there is another work for digit recognition. and there is a work for phoneme recognition, which is mistakenly probably called letter recognition. The authors collected some data for the phonemes. Maybe the most important work in developing a continuous speech recognition system for Kurdish is this work which a large speech corpus, also a large text corpus are collected and also a manually corrected lexicon in order of some commercial speech recognition applications are provided. This work, as you can see, it uses both classical hidden Markov model and new deep neural network for modeling the Kurdish speech and receive this accuracy. To have this work, we work nearly 4 years to develop a speech corpus. First of all, we design a set of sentences that are phonetically balanced, and we ask people to read these sentences, and we recorded their voices. We designed 700 sentences. As you can see, some samples of this. These 2 sentences include all phonemes of Central Kurdish. As you can see, there are not very popular sentences. They are artificial sentences to include all phonemes. For collecting the data, we used both office speech in and record the sentences in an office environment, uses some predefined microphones, and also we have utilized crowdsourcing using a Telegram bot. The result of this work is collecting 47 hours of speech for Kurdish language, which is the biggest and largest speech corpus. There are some statistics about the corpus. Also, we have designed a test set including different topics and record some data. Also, the adaptation set, which is commonly used in commercial speech recognition system to adapt the speaker voices to the system. In addition to the speech corpus, we also collected a text corpus called Acoustic text corpus, which is 160 million tokens from different sources. Some colleagues of me had a trip to Kurdistan region and asked the publishers, asked the organization that they have electronic text and magazines and newspaper, and select the data and they give us some of them. They give us their data, a part of their data, and also we crawled more than 50 websites, and after the normalization, this raw data, we received this size of corpus. There are various challenges for normalization text in Kurdish. Some of them are listed here and also are reported in the papers. For example, there are various types of writing a word in Kurdish, just like many other languages.
You have only 30. And I feel free to speak in Kurdish to explain your work, because some of the attendants may be preferring to understand your work in Kurdish language as well. So you have 1 minute for that and 2 minutes for finishing your work.
So I thought that I have more time than that. However, I will speed up. Also, we have developed a lexicon, and there are there are many examples of challenges in developing a lexicon. The group that did this work is called Acoustic, and we have published some of our data at GitHub, and there is our first version of speech recognition system, which is called Jira. Also, there is another work from the Amazon Common Voice for the Central Kurdish, and for the Kermanji Kurdish. There are good data set now is available for Kurdish speech recognition, and a guy which his ID is here used the XLS Facebook pre-trained network and used the Amazon data to develop a speech recognition system for Kurdish. However, as you can see, the word error rate is very high. During the last 2 years, we have enlarged our speech corpus. Also, we have
بەناوی خودای گەورە و میهرەبان. ئێمە کەین گروپی توێژینەوەی زانکۆی سۆران کە بە سەرپەرشتی دکتۆر هادی وەیسی کە لەلایەن بەڕێزیانەوە دامەزراوە.
We have developed such system. In speech retrieval, we don't have in audiovisual speech recognition, we don't have any work in Kurdish. For the text-to-speech technology, there is a long history for text-to-speech technology. For text-to-speech technology, we have 3 works from my friend Dr. Zahira Azami. These 3 works of concatenation-based speech, and also there are 2 other works. Among of them, the last one, which is supported by Kurdistan region, is a commercialized TTS system, which we didn't find any formal reports about this research. However, there are some samples of this voice. Maybe this is the major work in Kurdish TTS, which I think it's utilized deep learning. Also, we have developed a TTS system for central.
We have
Okay, sure. We have developed another text-to-speech Kurdish using end-to-end deep learning. We collected about this hour of voice, and you can.
روبرت لیڤاندۆڤسکی ئەستێرەی یانەی بەران بۆ دوام جار لەسەر یەک ناسناوی باشترین یاریزانی ساڵی بەدەستهێنا.
For voice conversion, there is no works in Kurdish. Also, for the dialogue system or digital assistant, there are many digital assistants nowadays in your pocket or on your cell phone or your computer, which there are only 2 works on text chatbots. I found there is no speech-to-speech dialogue system, of course. This part of the chatbot we call text-based dialogue system. For speaker recognition and dialect recognition, also there are some works. However, speaker recognition, I think, is a language-dependent technology. There are other language-independent technology, and of course, there are some hybrid application. And my last slide is about the research where are focusing on the basic acoustic analysis of Kurdish language, most of them for different dialects and different branches of Kurdish language, analyzed Kurdish vowels. And thank you very much. زۆر سپاس لە هەمووتان.
Thank you very much for perfect presentation. Thanks again for your perfect presentation, and thanks for choosing this kind of topic, because we as Kurdish need to improve ourselves in different skills for related to smart computing. So
thank you very much, Doctor.